All right, so we're going to start chapter 1, which is just going to refresh your memory a bit on hypothesis tests that you did in Stat 130, and then introduce this idea of a p-value to you. So let's look at what a statistical hypothesis is. So it's an assertion, which is a claim, assumption, or hypothesis made about the value of some specific population parameter. So we denote in general a population parameter by theta. But we know that that population parameter could be a mean, a median, proportion, standard deviation, variance, and so on. So there's many different population parameters that one may be interested in studying and then performing a hypothesis on concerning its specific value or range of values. So just to remind you about the notation, we reserve capital X for a specific value or random variable value in the population, and the value in a sample is then given by little x. N is your population size, that's capital N. Little n is the sample size. Sigma is the population standard deviation, and its sample equivalent is given by S. Mu is the population mean, and X bar here is the sample mean. So this should be notation that you are familiar with at this point. So this concept of hypothesis testing means you're testing a statistical hypothesis, which is a claim, to determine if the claim is true or not, and to determine to what extent it is true. So that's why our results are generally based on some sort of language of probability, which can be represented in terms of a significance level or confidence interval. But we are never 100% certain of our results. Okay, so that's just something always to keep in mind when you are performing any statistical inference, that the results, we are never 100% sure that the result is accurate. So the null hypothesis, so before we start a hypothesis test, we have to state the hypotheses, which consists of a null hypothesis and an alternative hypothesis. The null hypothesis, which we denote by H0, is a statement concerning the exact value of the population parameter of interest. That is stating that theta, whatever theta may be, is exactly equal to some specified value. Now, your alternative hypothesis is then a statement about the possible values that the parameter can take on if the null hypothesis is not. Okay, so, and if you remember, we only test one alternative hypothesis at a time. So the null hypothesis is always the same, but we can choose among multiple different alternative hypotheses. Do you remember the type of hypotheses, the alternative hypotheses that we could perhaps test? What are they called? What do we refer to them as? Anyone want to give me an example of one of the alternative hypothesis statements that we could make? Anybody have an idea? Yeah.
Okay, we could test that the null hypothesis could be created some specific value of population parameter, or else we could test if the value of parameter is less than some specific value,
Yeah.
which is theta naught, or else we could have a two-tailed test.
Correct. So you're on the right lines. Thank you for your answer. I just also want to remind you that if you're not speaking to me, answering a question or asking a question, please mute yourselves. Okay, please, can everybody ensure that you are muted? Thank you. All right. So as the gentleman suggested, we can carry out a left-tailed test where we are now testing if that population parameter should actually be less than the specified value in the null hypothesis. Okay? Or we could perform a right-tailed test where we are testing that the parameter should be greater than that specified value. Or we could perform the two-tailed test where we are just showing that that population parameter is not equal to the specified value. So we either have to prove that it is less than the specified value or greater than. Either one would give us the result that we require to prove that it is just simply not equal to that specified value. So we know that there is always some sort of level.
Sorry, ma'am.
Yes.
I have a question here.
Yeah.
I want to know that is that true that the null hypothesis and the alternative will be mathematically opposite to each other in terms of the signs?
No. Okay, so remember, for a null hypothesis, you have these three different alternatives. So it's not proving the opposite. Okay?
Okay.
The null hypothesis is that it's exactly equal to. So depending on your alternative, you would have a different mathematical procedure or statistical procedure to prove that alternative. And it changes based on the alternative. Okay, so statistically, it's not seen as the opposite. Okay.
Thank you.
Pleasure. All right. So it's the procedure of performing the test, no matter what the alternative is, it's the same. It's just the way in which you determine your rejection rule changes depending on these alternative hypotheses. And this is obviously something that I'm also going to be recapping today. So the actual procedure of, or just maybe not actually going through the exact procedure of what you did in Stat 130, but only when we get to extra examples in this section will I go through those exact procedures. But your rejection rule changes dependent on these alternative hypotheses. But the way in which you calculate your test statistic is the same, no matter what the alternative is.